my name is Hannah Finley, and I am completing Sierra College's 210 lab, lab 1, some properties of charge. So in part 1, I got to choose one of the, I chose the one with the balloon since it was given to us. So I'm just going to rub it against my head, and as I'm doing that, I gain a negative charge. I'm going to put it on the wall. Oop. Didn't do exactly that one. You should be negative charge to the balloon. Why is it not working right now? Okay, it should have a negative charge to it. Hold on. And it sticks to the wall. It literally bounced on and off of the wall. Sorry, that took so long. So basically what happened was as I rubbed it with the fur, it created a negative charge, which when I put it against a wall, which should be positive or neutral, it had hydrostatic force between it, and it like bounced off and slowly went down the wall. It tried to stay as close to it as possible. Whereas now that it's grounded, if I put it against the wall, it's still trying to hold on to it a little bit, but it's like there's just a pressure, there's a force between the wall and the balloon, and it'll stick to it as long as possible. As the electrons go into the wall though, if it was a truly charged up, it should just, against a positive force, it should just stick like that. And then as the electrons go into the wall, it should just fall. So that's why when it bounces off the wall, that's it trying to stick to the wall as much as possible. Part 2 of the lab is I will start with the metal can, which is right here. Let me get to the PVC rod. By rubbing the wool against the PVC rod, I am adding a negative charge to it. And as I bring it close to the can, it should be attracted to it. This is because in the can, it is separating. So this is negatively charged. So when I bring it, now that I've grounded it, it won't be attracted. But when I bring it close to it, this is negatively charged. The side that's closest to this, it will repel the other negative, like the other electrons. So the other electrons will go to the other side, and then the protons will come to the other, and that's why there is an attractive force between it. Okay, for this next part, I'm going to bring you closer to the electroscope I made. You can slightly see the two things in there. I'm just going to ground it before we start everything. And basically what's going to happen is I'm going to charge up this PVC pipe with a negative charge. And the metal thing in the inside is basically just a conductor, which means that it's basically just going to react to the charge I'm creating on here. And then as I tap it, the two rods in there, they slightly separate and then they go back to normal. So they should slightly separate and stay separated. And then once I ground it, they should go back to normal. And this is because when you create a negative charge, they are repelled against one another because they are the same charge. They don't want to be attracted to one another. It's very instantaneous and you probably can't really see from the lighting, but it will slightly move when it's initially touched. And this next part, I'm charging this up. It's going to have a negative charge. I'm just going to hover it over this. You can tell it's reacting. They're separating a little bit. I ground it with my finger, pull my finger away, pull the charge away. Initially, very small because this is not the best setup, but basically what I'm doing is I'm charging it up. It's not, but I'm not touching, so there's no electrons being transferred into it. It's just slightly making it repel because it's just, this is negatively charged, this is negatively charged, which makes them repel. So basically when I do that, but then once I ground it, I'm taking some of the electrons out, which means that this is becoming a positive force. And then once I remove this, basically the things should go out a little bit and then basically just level out. Technically they shouldn't level out, but they will level out over time as they lose the negative charge. And then the last part is to use, I've yet to be able to recreate this very well with the silk. It's been a struggle with me. I've tried this like 10 times. Hopefully this works, but I'm basically just trying to create a positive charge by using positive and negative silk, and this is through the Triboletic series. Silk creates a positive charge when rubbed against glass. And then when I bring it to them, the two rods should technically be attracted to one another because it's a positive charge. And that's how you can determine whether the metal is positive or negative charge, because since it was the PVC rod made it just move away, not be attracted, repel each other, it's a negative charge. This will just basically make that this should attract them. So there's ever so a slight movement in there. It was not the most crazy amount, but it was just enough to know that this is a negative charge or a positive charge. Okay. Moving on to the electrophorus. I'm going to start by rubbing it with the wheel, which basically is just adding a negative charge to it. Okay, I've created a negative charge. I'm going to add the plate. And basically what is happening right now is this is an insulator, which is keeping the charge bound to it, the negative charge. And the plate right now is just taking the electrons, and the parts that's touching the plate is all touching the insulator is going to be positive. So the center of the plate's positive right now because the electrons are being repelled from the electrons in the insulator, which means that the rim has most of the electrons, trying to get as far away as possible. So when I touch it, there's a slight shock. I can feel it, you can hear it, and that's just the electrons coming into my body. If I pick this up, now it's mostly a positive charge plate. Let me just bring it close to the camera so you can see the light bulb. The light bulb slightly went red. Now I bring it over here and I slightly hover it over and I touch the light bulb again. It's red. That's because some electrons are going back into the plate and into me. I bring it away once again. I was shocked. I bring it back here. Now I'm going to lift it 2 feet above the insulating base, and I'm going to touch the top or the light bulb ground. There's no charge to it, basically. Okay, and I pull it away, and there's nothing. So basically what is happening is that when I put it on the insulating block, the electrons are basically moving to the edge of the plate. As I touch it, electrons transfer from me to make it more leveled out with the insulator. The electrons are trying to leave because of the negative charge there. I pull it away, and now that it's mostly positively charged, and I touch it again, that's why the light bulb lights up, because the electrons are running through the wire back into the plate, because I created mostly positively charged. Now it should be basically neutral. I bring it back over this, and basically it's feeling the charge. There's the electric field is there, a negatively charged electric field. So once again, the electrons are trying to move far away. I touch the light, it lights up. And then I pull it away. Once again, it has mostly a positive charge because the electrons left because of the electric field. And in the previous example, then I get shocked And then once I bring it back over here, but it's 2 feet above, the electric field is so minimal that there is no longer, this is now zeroed out. There's no longer anything trying to repel the electrons out of the plate. Hence why there's no longer a shock. Okay, let me rub it again. And basically what I'm going to do, I'm creating that electric and negative electric field again. I'm going to touch the plate. I have a shock. So now this plate is mostly positively charged. Now if we come over to the pieces of paper here, you should be able to see the papers be attracted to the plate because it's mostly a positive charge now. They don't move much, but they do move slightly. So let me try that again, and I might just move the camera right there. Oops. There we go. Nope. There we go. Okay, let me just try that. Oh my god. Let me just try that one more time. Making it a positive charge. Let me pull that away. Yes, and you can see the paper lifts up and is attracted to the plate. And that's just because they deposit paper. I mean, the paper is in charge, and it's negative charge, and then the plate is a positive charge, hence the attraction. And then the reason why I can repeat steps in 3, 4 basically indefinitely is because every time I'm just adding and subtracting charge, and the insulating base is bounding charge. So it's going to keep having that electric field, hence why the electrons keep coming and leaving the plate as I keep grounding it. Thank you very much.